Here are the notes for today. You may have heard these notes, so if you did, great. If you didn't, you may want to take some notes while you're listening to this. The competitive exclusion principle we did already talk about. It's talking about competition, that no two species can occupy the exact same niche at exactly the same time. Same thing for the habitat. You can have that happen occasionally, but it's incredibly rare. You will have a winner and a loser. So what happens if the loser sticks around? They end up being excluded from the resources and end up decreasing in population. The predator-prey relationship is talking about the predator-prey relationship being one species is feeding on the others. You're going to look here that the predator is consuming the hare as long as the population goes up in population of hare, so do the lynx. When the population of the hare goes down, so do the population for the lynx, and you see that over time. This is the same thing, the graph here. However, the predator population will eventually limit the food supply, which is called carrying capacity, and we'll see that here in just a second. Let's talk about a few population growth vocabulary words. Population density is talking about the number of individuals per unit area, so how many people live in that area. Growth rate is talking about how much population is growing over time. Is it increasing or decreasing? So you could think about the population density of how many people live in Indianapolis, the growth rate of looking at how many people are coming and going, living in the Indianapolis area. Now remember, we're talking about population growth of organisms, not just people. Population density, growth rate of species. There's what makes a population density change is you have extinction, which is organisms dying, competition, where they're competing for the food, birth rates, obviously babies being born of whatever species, death rates, the number of deaths of those at a given time, and migration, leaving to go somewhere else, like for example the winter. We have that a lot happen here in Indianapolis or in the Midwest. So here's our growth curves. This will go back to limiting the organisms, the predator and the lynx hare conversation. This is going to fit right in. So exponential growth is talking about if there were no predators, the hares would just go exponentially grow. There's nothing stopping them from growing. So you have a J curve, which goes exponential. You see it starting here, looking like a J, going increasingly, nothing stopping it. Exponential growth is like at the wolves in the Yellowstone Park. Without them, the animals had exponential growth and destroyed the ecology in the area. So they reintroduced them. Logistic growth is more reasonable. You're looking at logistic growth looking like an S curve. And this is where it starts off being exponential, but something limits it. And in the case of the hare lynx, the lynx are what limit the carrying capacity. So they consume enough organisms to keep it at carrying capacity, which is carrying capacity definition, maximum number of species that can support an environment. So you can't go beyond this, or a species has to change. So for example, here's where it overshot that carrying capacity. That's that line here, the purple. We'll call this red. I'm not sure if that's red or pink, but the overshoot is where the organism went way above the carrying capacity, which means at some point there was not enough resources to keep them at that capacity. So then they fell below it until they could recover, and that means they had enough resources to come back. If you consume all your resources, you're going to go below that line. If you have resources to maintain, it'll go above the line, and so on and so forth. You want to have a pretty good S curve and stay at carrying capacity, not overshooting, because that means something has to happen. What limiting factors are there? There's competition, predation, disease, natural disasters. There's a decrease in birth rate and increase in death rate, and you see that when you're above the carrying capacity, so that's what keeps it limited. There are two types of population growth. There is density-dependent limiting factors and density-independent limiting factors. Density dependent limiting factors, these are dependent on the actual size of the population, and they can be caused by competition, predation, and human activity like overfishing, hunting, and effects on migration patterns and disease. The density independent factors, these will affect population size same way no matter the population size. Examples include natural disasters like wildfires, droughts, and floods, and then human activity. If you have a population size that is small, these are some of the problems that come with it. There's inbreeding, which means they breed within their community. They decrease the genetic variability and the biodiversity. It leads to populations that are not able to adapt to change, which means that they will not survive because they're not able to adapt. It leads to sick animals and dropping of numbers, and then that leads to extinction. Many animals that were on the brink of extinction have been Siberian tigers, cheetahs, polar bears, bald eagles. We've had several that have been put on the list for extinction and have found a way back by doing different things to help them obtain that goal, like interventions, creating safe places for them to regrow their population. Okay, this is for today's lessons. This is level of organizations. We're talking about individual, which is an organism. If I'm talking about one single individual, I'm talking about one organism. And as I have more than one organism, that would be a population, which is a group of the same species. Look at the little pictures. These pictures kind of guide you along the way. Community is a group of different species living together. See all the different ones living together there? Ecosystem is anything non-living and living. So the rocks, and that's kind of giving you an idea that it's a non-living. Rocks are not living. Neither is water. Maybe the microorganisms in it are, but they're not. And water itself is not. So that's an ecosystem. As I get larger, include more ecosystems in a group, I'm looking at a biome. And then if I'm looking at the entire Earth, I'm looking at the biosphere. And that would include all living and non-living. Okay, we will talk about recycling in the biosphere on Tuesday. So be sure to look over this and then complete the lessons that are on Canvas. And that's it for today on here.